Since last 1 week, we are doing many sessions over here, farming sector. Village guests are guests had come from over here. Like our there is Saturday and yesterday last week, and they had delivered the sessions later. So they are relatively lucky to have such endless speakers over here. Today we have Dr. Chetan Tendulkar, assistant professor, Vedanthani College of Engineering, Department of Mechanical Engineering. So, sir, I have total experience of 14 years. Area of specialization, computer-aided design, computer-aided manufacturing, industrial engineering. Uh, at the moment, Sector sir has guided nearby 8 batches, 40 students, PG 2 batches, number of papers published in International Journal 20, SCR focus in peer review journal, national journal at the moment there is no. International conferences, 11 conferences there, number of books published, 1 book is there, number of awards, 1 award sir has received, professional body teacher, name of the professional body, Indian Society of Biomechanics, Association of Machines and Mechanism, IAM, International Association of Advanced Materials, International Association of Innovation Professionals, International Association of Engineers, Society for Technologically Advanced Materials, Best Researcher Awardee, first edition of International Research Awards in Welding Technology, Welding 2020. So, Sir is a very experienced person, and we are really glad to see that Sir is among us for delivering this session. So, I'm requesting Sir to start up the session. I'm really sorry. Actually, we need to welcome our guests of honor. So, I'm requesting coordinator of this as an activity program. I will confess to welcome our guests of honor today with a small. Thank you very much, sir. Now, I'm requesting Sir to start off the session.
So, good morning, one and all. Present here. So, I am Dr. Chetan Tendulkar. My specialty is in computer design. I am assistant professor in University College of Engineering. I have done my PhD from W. Professional University of Harvard. I have published more than 20 interactive projects in HPI and Photos, which are peer reviewed. So, my topic today will be on transient analysis of Austenitic and Ferritic stability. Okay. So what is transient analysis? It is an analysis with respect to time. So, so these are my contents. That is introduction about the topic. Then how to improve the production cost. Then finite element analysis. Then welding model, mesh model. Result and discussion and conclusion. So in various industries such as chemical industries, petrochemical industries, and oil industries, they use E16L austenitic stainless steel for various purposes such as walls, boilers, and various other things. So these are various boilers or chemical storage where in the chemical industry these are used. These are made up of E16L austenitic stainless steel. So nowadays, the nickel price is increasing. So the nickel percentage in C16L austenitic stainless steel, this is increasing. So the cost of C16L austenitic steel is increasing. So how to uh, make another material which is available, which is the same, which is having the same strength and which gives same properties that of 316L austenitic steel, such as we can replace this 316L austenitic steel with another material. So the 316L austenitic stainless steel is used for making walls, then for chemical storage and other things. So how to make replacement of this 316L austenitic stainless steel by another material? That is my research. Next. So there are many industries such as chemical, petrochemical, oil industries, and various types of industries such as nuclear industries, which are using this austenitic stainless steel for using walls, then construction of boilers, pipelines, etc. So this austenitic stainless steel is very good material. It is having high ductility and very good corrosion resistance. These are having very good mechanical properties as well as corrosion properties. Therefore, these material are used for these industries for making walls, then boilers, pipelines, etc. Around 60 to 70% of this market industries are using this austenitic stainless steel because it is having good mechanical properties as well as corrosion properties. So how to replace this 316L austenitic stainless steel by another material which is having same strength and better corrosion properties. So if there is a if there is failure in some part of this material, that is 316L austenitic stainless steel, which are using for making walls and construction of boilers, then replacement of all the boilers is very difficult. So if there is a some part of failure in 316L austenitic stainless steel wall, so we can weld part different materials and we can use those walls for many years. So my research is that how we can weld those those failure parts by another material, so we can improve the cost of this what is called as production cost and how we increase the performance of that material and how we increase the production cost of that material. Okay, that is my research. Next. So as the price of nickel is increasing, the nickel in austenitic stainless steel may make it a more expensive material. So the manufacturers of this austenitic stainless steel are looking for another material. So the better alternative, which I have been researching and I have been researched in many papers and I have published many papers on this, that is Ferritic stainless steel is the better alternative of this austenitic stainless steel because of its cost effective and the amount of nickel in this Ferritic stainless steel. The amount of nickel in Ferritic stainless steel is less, therefore its cost is less. So therefore, this is a better material, which is ferritic stainless steel, which is better alternative of austenitic stainless steel. Because, however, there is a problem in ferritic stainless steel that it has low bendability and that is a grain growth in heat affected zone and weld zone resulting in low ductility and toughness. So for this, the selection of fillers is very important. Selection of fillers is very important for uh, for decreasing this grain growth in the heat affected zone and weld zone. So therefore, a careful selection of fillers and welding process is important in this weld, that is weld with ferritic stainless steel to provide sound weld joint for similar joint, that is austenitic stainless steel and ferritic stainless steel. Next. So my study is on temperature distribution analysis in the gas tungsten arc welding, where two dissimilar metals are used, that is 316L austenitic stainless steel and coated to ferritic stainless steel, with two filler materials, that is 309L, ER309L and ER316L, and one with without filler for three different samples I have used. First, I have welded with ER309L, second ER316L, and another with without filler. So three samples have been performed in transient analysis of FEM. So the transient thermal analysis was performed to obtain the temperature distribution across the weld zone during the welding operation, and 16.0 is used for welding operation. Next. So the transient thermal analysis is to find out the temperature distribution because it gives better results. So different welding conditions are taken and the simulation of this welding process is conducted in NCs. These are the process parameters for welding. Next. These are the assumptions which I have taken during analysis of this welding of austenitic stainless steel and ferritic stainless steel. The material properties are assumed to be isotropic. Then heat flux is constant at the welding zone. Then convective and radiative heat losses occur at all three surfaces, and gas tungsten arc welding with and without filler is modeled in this ANSYS. These are the heat source and boundary conditions where Q is heat input and V is arc voltage, I is welding current, and V is welding speed. Next is the transient equation of temperature. T is temperature, Cp is heat capacity, rho is density, U is heat conductivity. Next. So this is the welding model which has been developed where these two plates are welded in ANSYS, where root gap is maintained of 1.2 millimeter. The dimensions are 75 millimeter into 3 millimeter into 100 millimeter into 3 millimeter. 3 millimeter is thickness, 100 millimeter is length, and 75 millimeter is width. So these are the chemical composition of this 316L austenitic stainless steel and 430 ferritic stainless steel. Where the nickel component of this 316L austenitic stainless steel is 10.06 percentage. So that's why this material is beneficial. Its mechanical and corrosion property is greater in this 316L austenitic stainless steel. So therefore, this material is costly. So we have to look for another material for this 316L austenitic stainless steel. Therefore, I have chosen 430 ferritic stainless steel, where this nickel percentage is less, which is 0.110 percentage. These are the mechanical properties of these two materials, which is 316L austenitic stainless steel and 430 ferritic stainless steel, where tensile strength is somewhat same, density is same, but the yield strength of this material, that is 430 ferritic stainless steel, is greater. And also the melting point of this 430 ferritic stainless steel is greater. It is 1425 to 1510. And yield strength is also greater. So the mechanical property is greater for this 430 ferritic stainless steel. So we can easily replace this 316L austenitic stainless steel by 430 ferritic stainless steel. This is the meshed model of two welding components where element solid 183 is used for meshing. Next. So these are my results where transient analysis is performed for different materials. So first, the filler is used as ER309L filler, where this transient analysis is used. So the time is for 20 seconds. For 20 seconds, the temperature achieved is 604 to 4440 degrees centigrade in ER309 ER309L filler weld. The next, for ER316L filler weld, for same time 20 seconds, the temperature is 602 to 3980 degrees centigrade. Previous slide. So the temperature achieved in 316L filler weld is less than this 309L filler weld. question next. In without filler, the time is same. The temperature achieved here is 768 to 5680. So as compared to 316 L filler weld and 309 L weld, the temperature here is greater. It is 5680 degrees centigrade. So the heat affected zone and the weld zone which are getting in autogenous weld is somewhat greater. The thickness of this weld zone and heat affected zone is greater. So the failure chances of the material by autogenous weld is greater, and the failure chances of by welding 316L filler is less. So we can use 316L filler for welding this two dissimilar metals. So that is my conclusion. Next. So it is observed that the maximum temperature across the welding zone increases as the tool holding time increases. Therefore, the 316L filler which is used for to weld these two dissimilar metals, we can use by the two welding by 316L filler metal because the temperature achieved is less and the heat affected zone is less. So the failure chances of welding by this material by 316L filler material is less. So the prediction of analysis can be useful to predict the heat input parameters which can be used for experimentation. By means of this analysis, we can say that 316L filler material can be used to weld 316L and 430 Ferritic stainless steel. So the replacement of this 316L Austenitic stainless steel by 430 Ferritic stainless steel we can do by means of this welding by 316L filler material. So that is my conclusion. Thank you. हाँ वो जो फिलर मटेरियल अपन यूज किए इवन के सेल फिलर जो मटेरियल यूज किए जाते हैं उससे किए तो वो जो कोरोजन जो आता है अपने को कोरोजन रेट भी वो मैंने इसके नहीं पता है पर जो कोरोजन रेट आता है वो बहुत कम आता है